Chemistry in war. Chemistry has brought chemical weapons to war. These weapons are extremely dangerous and really harmful to the environment and people. They are mainly gases such as the tear gas, the chlorine, the phosgene, the diphosgene, and one of the most harmful gases to ever be created is the mustard gas. Chemical weapons were first used in World War I. They were designed to incapacitate targets. They were not deadly at first, but then people start searching for new ways to kill people with these chemical weapons. Then they start evolving it into, again mentioned, the chlorine and the phosgene and diphosgene. They killed a lot, almost 100,000 of deaths from World War I were of these gases. Instead of stopping the use of chemical weapons in war, people didn't learn the lessons. Instead, they used them again in World War II. This led to one of the most hazardous attacks ever, the Nagasaki bomb.
Chemistry and global warming. The first thing that chemistry affects is the carbon dioxide that is made by the combustion of trash. The other thing that affects the global warming is the methane gas that is made by the composition and combustion of the trash. Also, the excrement of animals can affect the global warming because it has chemicals that affect the But chemistry is not that bad. It also helps the global warming. How? Well, the chemistry also helps with eolic energy. The chemistry also helps the environment by making cars that work with solar because it doesn't damage the ozone layer. It's not that bad, but it's not so good because it helps the environment, but it also damages it. So that's all.
2000 to 2009. It was the warmest decade on modern record. How do we know? It's what we do. NASA has satellite missions monitoring climate. They're up there right now, gathering data, analyzing trends, and sharing both raw data and results with everyone for free. Why are temperatures rising? Why aren't changes the same everywhere? How are humans contributing to climate change? What changes are already occurring today? Find out for yourself. Our warming world at nasa.gov.
Climate scientists at NASA's Goddard Institute of Space Studies, or GISS, just released a new analysis of global average temperatures showing that 2009 was tied as the second warmest year ever recorded. And looking just at the southern hemisphere, 2009 even broke the record as the warmest year ever in this half of the world. In fact, 2009 was virtually tied with 5 other recent years in its position as second warmest on record: 1998, 2002, 2003, 2006, and 2007, and it was only a fraction of a percent cooler than the warmest year, 2005. Yet when looking at global temperatures over a longer time frame, these scientists found a persistent warming trend over the past 3 decades, with the average global temperature increasing by roughly 1/3 of a degree Fahrenheit per decade. This past decade, from 2000 to 2009, was the warmest yet. And when looking back all the way to 1880, the year when precise temperature record-keeping began, scientists observed about a 1.5 degree Fahrenheit rise in global temperature.
There are already beginning to be effects of 1 or 2 degrees warming, and if we get 5 or 10 degrees warming several decades downstream, there will be huge effects.
GISS scientists came to these results after analyzing information from 3 sources: data from more than 1,000 weather stations around the globe, satellite observations of sea surface temperature, and measurements from Antarctic research stations. So what's the cause of this long-term warming trend? While there are several natural processes that can cause subtle climate warming or cooling, like variations in solar activity, fluctuations in ocean currents, and volcanic eruptions, climate scientists believe that the rising levels of carbon dioxide and other greenhouse gases are the dominant factor driving the rise.
If we want to limit climate change and keep it under an additional 1 degree Celsius or 2 degrees Fahrenheit, we would need to begin to decrease the CO2 emissions gradually so that by the end of the century, CO2 stopped increasing.
So while 2009's temperature may not have been the global record breaker, it is in line with the long-term trend, telling scientists that the planet is getting warmer.
Chemistry can affect medicine by 2 ways. Diagnosis. Many diseases are diagnosed by simple chemical reactions. For example, to determine the blood glucose is a reaction. Synthesis of new medicine. Imagine you find a plant, and from that plant you got a substance that has an effect, but it's minimal. Well, with organic chemistry, that effect you can add, remove, or modify the functional groups to make it much more effective and need a small doses. Atoms and combinations of atoms makes up all substances, including food. Chemistry studies how atoms interact with each other. When you heat, freeze, store, or mix food, you are making changes to the atoms. So all boils down to chemistry. Food chemists are experts that study how atoms react, and all boils down to chemistry. Food chemists are experts that study how atoms react to those changes. Use filters in the chimney of industries and reduce the emission of CO2. Use the collective transport to decrease the emissions of carbon dioxide and other contaminants. Reuse plastic bottles, bags, and containers to decrease the use of plastic and trash. Establish laws to not burn fire of trash, grass, and other things at the natural environment.